Hello and welcome to the 2024 User Day, and thank you for joining this session on BOSfluids. My name is Mark Groen. I'm lead software engineer at Dynaflow. Later today, this session, I will be joined by Erik-Jan Linge for the Q&A. So this session is about the new features of the upcoming release of BOSfluids. It will consist out of two parts. So for the first part, I'll be giving a brief overview of all the new features in BOSfluids version 7.2. And after that, we'll have a live interactive Q&A session. So if you have any questions at all, also during the presentation, please sure to write them down in the chat area and we'll try to answer all of them. So first, let's start with the upcoming features of BOSfluids. As you're used to with new major releases of BOSfluids, this new version includes various new features and all kinds of smaller and larger improvements to the existing features. Let's take a look at some of the highlights. BOSfluids 7.2 has been extended with new database categories. So if you open up BOSfluids, you can access the database by going to Tools, Database. So over here we have the already existing categories: fluids, materials, and unit sets. And these have now been extended with also nodes, elements, and pipe schedules. So the pipe schedules were already built in explicitly or implicitly by in the previous versions of BOSfluids. So the NC nominal pipe sizes, you could enter, for instance, just 10 in your diameter field, and it will automatically translate that to a nominal pipe size of 10 inch. These pipe sizes have now been made explicit in the database, so they can now also be extended with your own definitions. So next to the nominal pipe sizes, we also added the built-in ISO norms, so for the DN schedules. And as I said, you can extend these with your own definitions. For instance, if you have GRE piping, you can start with a new let's say pressure class 12.5 bar. We'll group it GRE pipe series. Already have a Excel file with these diameters and thicknesses with a size ID appropriate to it. All right, let's save this one, maybe add another one. So this will call pressure class 16. Add it to that same group and load that and save it. All right, so if we now start building a model, and let's say, all right, we'll start with some steel piping, standard schedule, 10 inch. So it will get you the correct outer diameter and thickness as you're used to, but now it's also has this field pipe schedule where it says the NC standard schedule. All right, let's apply this and continue. Let's say that we have a spec break over here, and we go instead to the DN. So that would be DN 250. So you see it basically is the same outer diameter and thickness. And now let's pretend we have a GRE pipe. So let's start with the pressure class 16. So that 250 DN 250 has now been transferred to a different diameter with a accompanying thickness. And if we switch to the pressure class to 12.5, we see that for GRE piping, which is custom, that you'll keep the same inner diameter, but you have a different wall thickness, and it will get that also automatically from that DN 250. So if we take a look at our fields, you see over here we have also now the pipe size. So you'll see that for the NC nominal pipe size 10 inch, the ISO DN 250, and these GRE piping, which all have also a 250 millimeter ID. So going to the schedule, you'll see that for the schedule you'll have the different pressure classes now also shown in the in this fields viewer. So let's go back to the database. So as I said, we also have nodes and elements. So over here you can just simply add a element definition. Let's say we have a valve XYZ, and it has some properties. Oh, that's a bit arch. So it's now being saved in a database, so you can use it for later access. Let's change this one to that valve. To do so, you'll go to load from database and select our valve we just saved, and we apply the changes to include that valve in our system. And now if you use it during some other project, you can easily make use of that same valve again. BOSfluids 7.2 has improved the way you save your preferences. So if you go back to our model, in the user interface we now have the option model settings and model preferences. So in the model settings, the settings for this specific model are saved. In preferences, you can set your own preferences that will be used by default for any new models you'll make. So in preferences, you can set some settings like the node increment and the numerical format you want to use, and also the unit sets, the view mode, 3D or 2D, and the vertical axis. Also, you have this option to make your user interface more clean. So for instance, if you're not using the structural model, you can deselect this option, and then all options and fields that are tied to just the structural interface are now hidden. So this will only leave you with the specific fields for your flow analyses. And also if you go to the analysis themselves, you only find the flow analysis and not the structural analysis anymore. So this also changed a bit how you select your units. So units are now also saved in the model itself. So no longer it's found under tools, but it's now found also under model settings. So the model settings include the unit set you're using for this particular model as well. For the new BOSfluids, we improved the performance of running simulations. So as you know, BOSfluids was already one of the fastest flow solvers out there, allowing you to run your simulations on multiple processing cores. So over here I run this simulation on 3 processing cores, and now we have even improved this further by scheduling the processor cores more smartly, so you can see it runs very fast. This 8 cases, of course, on a small system, run in just 8 seconds. And as we see on our flow grid, we have a very small time step, so just less than half a millisecond running for 100 seconds. So yeah, that's 200,000 time steps in total, and still it runs very smooth. For the new version of BOSfluids, we improved the PCF importer. So PCF files, or piping component files, are used by large 3D programs. You can export your complete 3D design to these PCF files, and BOSfluids allows you to import these again. So this can greatly help you when you need to build a system. Well, why you do it again if someone has already the complete 3D model in a pipe stress package or a big CAD program. So just importing these PCF files in BOSfluids is very easy. You just select the PCF files. You can import multiple of them. So in this case, as you see, I'm importing almost 2000 PCF files. And for the new version, we improved the way the pipe specs are recognized by BOSfluids, and also the different components that are in the PCF files, how they are translated to BOSfluids. So if you just import this very big system of almost 2000 PCF files, you'll see that it has 31,764 different elements in it. It's so large that the rendering is so small you have to zoom in to see the system. And you see that now it makes use of the new pipe specs. So the schedules are recognized, all the pipe sizes, and this can greatly help you just also running your system on the 3D model instead of a schematic. Improves the accuracy of all your forces and the results, and makes it easier to communicate again back to the design team if there are any mitigations required for large forces, for example. The new BOSfluids comes with a new scenario manager. So we have changed a bit the layout of the scenarios tab to have the scenarios listed as such you see here. So you can select now multiple scenarios and change settings and parameters of multiple scenarios at the same time. Of course, this still works if you need to have your changes applied to all scenarios. You can change the main model, but now you can have separate changes applied to multiple scenarios at the same time. And you can also pop out this new scenario manager. This scenario manager gives you a quick overview of all the changes between the scenarios, the differences. So you can just click on an item. The viewer will also zoom to that item, and this scenario manager allows you to see the differences between them, but also allows you to edit any changes or even if you go to fields that require tables and such, you can also edit them at the same time in this scenario manager. You can select multiple scenarios and compare them to have the differences also listed in a report as such. BOSfluids has now improved the accuracy when performing simulations with compressible fluids, so gases. So when running a gas-filled pipeline, such as this simple example, long pipeline, due to the pressure drop, you'll find that you'll have a decrease in pressure over your pipeline. So if I make a profile plot running from start to end, pressure decreases, so also density decreases. Of course, the mass flow rate will be constant because of conservation of mass, meaning your volumetric flow rate will increase along the pipeline. So for this model, I cut it up in all small pipe sections, but in this new version of BOSfluids, you can also run this complete system. So if I just merge these elements to one element and then again run it, you see that BOSfluids now applies some model refinement to actually take into account the decrease of the density and the increase of volumetric flow rate between the first and the end point of this system. So in this single element now, you also see that you'll still have that same increase in flow rate because of the compressible fluid we're using. So this allows again for a more accurate starting point when performing eventually any transient analyses. So the 2024 release of BOSfluids now also includes a firewater module. So the firewater module requires a separate license, and when this license is activated, it will give you access to additional elements such as sprinklers and surfaces. And using this firewater module, you can perform firewater analysis to determine firewater coverage. So in this module, we have a tank with a firewater system made out of rings with sprinklers. So one of these sprinklers over here on the roof of the tank. You can visualize the spray profile in the viewer over here. And when you run this analysis, it will basically make use of a steady state analysis to determine the pressure and the flow rates, just like in the regular version of BOSfluids. But it also gives you now a firewater coverage simulation. So this will show you the firewater flux on the surface of the tank. And this particular model also includes a variation, so a parameter study where the pressure is varied up to 7 bars to see what that does for your firewater flux on the surface of the tank. This concludes the overview of the highlights of BOSfluids 7.2. Of course, there are many more smaller improvements to be found in the program. But now I will give word to Erik Jan for the Q&A session.